All right, we're on to our last concept of today's experiment with our lava lamps. And our third scientific concept that I wanted to talk about today is polarity. So, you guys, this is some really advanced science concepts. It's okay if you're struggling a little bit with it. I just wanted to take an opportunity at the end of the year to have some fun and expose you to some different kinds of science concepts. So, remember this guy. Which molecule is this? This is our water molecule. And remember, water has some really cool properties that makes it do some really interesting stuff. And one of those things that's very interesting about the water molecule is that it has some different almost magnetic charges. So this side has like a positive charge, and these two parts here, the hydrogen, have a negative charge. And that's basically what polarity means. It just means that atoms and molecules have slightly positive and negatively charged sides. So we actually saw polarity in action in our lava lamp, which I'll talk about in just a second. I want to finish talking about this part really quickly. I don't know if you've heard this old saying that opposites do what? Opposites attract. And so that's still true in science, right? Um, we talked about in one of our last lessons that, oops, there goes my pen. We talked about in one of our last lessons. Haha, I got it. I'm trapped in with my little filming station over here. We talked in one of our last lessons, sorry, about um, why the water sticks together. And it sticks together because the sides are oppositely charged, and so it worked kind of like magnets, right? They stuck together. Well, what about when you flip magnets over? You can't always get magnets to stick together if they're on the same side. They do that weird thing where they push each other away. And that is true with molecules. What I have here is a very different representation of an oil molecule. I hesitated to find the right word because this really is not what an oil molecule looks like. This is just the best one that I could make at home. So for those of you watching that are out there saying, that's not an oil molecule, I know, but it's close, okay? So when the oil, this is our oil layer, you can see the food coloring is all diffused evenly now. When our oil and our vinegar, which acts pretty closely to our water molecule, when they interacted, the charges that are the same don't mix. They both have these negatively charged hydrogen sides, and look, they want to push each other away. So charges that are the same, charges that are the same don't mix. And so how we saw this in our lava lamp was through those perfectly round spheres. What was happening was that on all sides, the molecules are pushing each other away. And so since all sides were pushing on each other, that caused those perfect spheres to form because on this side it's pushing away, and on this side it's pushing away, and on this side it's pushing away. And so with the pressure being pushed on all the sides, it creates these perfectly round spheres. So not that you absolutely needed to know that in your life, but you guys know I'm a science nerd, and I thought that it was just a really cool thing to know and understand about why we saw those perfectly formed spheres.